Hey everyone, and welcome to this deep dive. We're going deep into the world of software architecture today.
Yeah, it's kind of like the foundation of any good software project, right?
Exactly. Think of it like, you're building a house.
Ooh, I like that.
Yeah. Would you rather have a house built on solid bedrock or like on shifting sand?
Definitely bedrock.
Exactly. And that's what software architecture is. It's about making sure your code, no matter how well written, can stand the test of time.
It's about those big picture decisions, not just the code itself, that make a system resilient, adaptable, all those things.
Totally. And we've got some great sources to dig into this. We're looking at excerpts from Building Evolutionary Architectures, Clean Architecture, that's a classic, and Fundamentals of Software Architecture.
Those are great choices. Each one kind of gives you a different lens to look at this stuff through.
Exactly. So let's start with something that I think trips a lot of people up, this whole idea of like indirect control in software.
Yeah, that can be a tricky one.
It sounds kind of like ominous, right? Like
Yeah.
I'm picturing some evil mastermind controlling things from the shadows.
Right. But really, it's about how different parts of your code communicate, how they interact, without getting too tangled up.
Okay, so less evil mastermind, more like traffic management.
Yeah, exactly.
Yeah.
Think about it. In the early days of programming, things were pretty wild. Like a city with no traffic lights, just cars going wherever they want.
Chaos.
Total chaos.
Yeah.
Then along came things like structured programming, and then even more so, object-oriented programming.
Yeah.
OOP, which is what clean architecture talks about.
So it was like introducing traffic lights and like lanes for your code.
Precisely. OOP brought in this discipline of saying, okay, these pieces of code, they have their own specific roles, their own boundaries. They can't just go rogue.
And that makes everything smoother, more organized.
Exactly. And speaking of organization, that brings us to modularity, which is something fundamentals of software architecture really dives into.
Right. Modularity is that about breaking down a huge complex system into smaller, more manageable chunks.
You got it. Think of it like, a well-planned city. You wouldn't want one massive building trying to be everything to everyone.
That would be overwhelming.
Totally. You want distinct districts, each with their own purpose, but they're all connected in a way that makes sense.
Makes sense. So applying that to software, instead of one giant program, you break it down into these smaller modules.
Yeah, and that makes it so much easier to understand, to maintain, to scale up later on.
I can see that, but isn't there a risk of going too far with this? Like, is there such a thing as too much modularity?
Oh, absolutely. That's where over-abstraction can sneak in.
Over-abstraction. Okay, now that one definitely sounds intimidating.
Right. It's like, imagine taking that city planning analogy, but instead of having streets and buildings you can easily navigate, everything is just a bunch of underground tunnels.
Oh, I see. So it looks organized from, like, a bird's eye view, but good luck finding your way around down there.
Exactly. And that's what over-abstraction can do to your code. Fundamentals of software architecture warns against creating too many layers of, well, abstraction, because it makes the system hard to grasp, hard to change. You need that balance.
Right. So we've got modularity, avoiding over-abstraction. But how do we even know if we're doing a good job? Like, how do you measure good software architecture? It's not like there's a ruler for it, right?
That's where things get really interesting. Building evolutionary architectures talks about these things called fitness functions. It's a way to measure how well your architecture is actually doing.
Fitness functions. So, like, is my architecture doing its daily push-ups and eating its vegetables?
Kinda. Think of it like, when a city inspector comes in to make sure a building is safe. They're not just looking at how pretty it is on the outside.
Right. They're checking the foundation, the wiring, all that stuff you don't see but are super important.
Exactly. Fitness functions are like those inspectors for your software. They help you assess things like security, performance, scalability.
So even if I'm not a coder myself, I can ask questions like, hey, can this system handle a sudden influx of users? Is it secure?
Exactly. You're thinking like an architect now.
That's amazing. I love it. So we're not just blindly building here. We've got these tools to help us evaluate and make sure our architecture is like truly fit for its purpose.
You got it. And that's what's so cool about software architecture. It's about thinking ahead, anticipating challenges, and building something that can evolve and adapt over time.
This is reminding me, we really need to talk about dependencies because I feel like that's where things can get really messy really fast.
Oh, dependencies. Yeah, those are a whole other can of worms for sure.
Like you change one tiny thing in your code and suddenly something completely unrelated breaks. It's like a domino effect of chaos.
It's the butterfly effect of software development.
Exactly.
And you know what? Fundamentals of software architecture actually has this concept, the architecture quantum, that I think really helps explain those dependencies in a visual way.
Architecture quantum. Okay, that sounds a little intimidating, not gonna lie.
I know, right? It sounds like something out of, like, quantum physics or something.
Right, like I'm about to need a PhD to understand
It's
this.
not that complicated. It basically means the smallest piece of your system that you can change without setting off a whole chain reaction of changes everywhere else.
Okay, so like if I change this one line of code, will it break everything else?
Exactly. You want to be able to make changes in one area without having to, like, completely rewire the entire system.
Right, so a good architecture quantum would be like having like modular components, so each part is kind of self-contained.
Exactly. And that actually segues perfectly into this whole debate about monoliths versus microservices
Yes, the age-old question. One giant application or a bunch of smaller ones?
and software architecture. The hard parts actually has a really cool case study about this, the SysOps Squad saga.
Oh yeah, I've heard of that one.
They started with a monolithic architecture, one big program that did everything,
Makes sense.
which worked fine at first.
Yeah.
But then as the system grew, it became a real pain to maintain. Like
Yep.
trying to add a new wing to a house that's already been built and is like maxed out on space.
Yeah, at that point you need a whole new foundation, right?
Yeah, exactly. So they're like, okay, let's break this monolith down into smaller, more manageable microservices.
So kind of like instead of having one giant house, they're building a bunch of smaller houses, maybe with like walkways connecting them.
I like that analogy. Yeah, the idea is to have these independent services that can communicate with each other,
Yeah.
but aren't completely reliant on each other.
Makes sense. But I'm guessing it wasn't quite as easy as just like drawing lines in the code and saying, okay, now you're a microservice.
You're right. They quickly realized that one big thing they had overlooked was, you know, data.
Data. Oh, right, because even if your code is all nicely separated, if everything's still talking to the same database.
Then you still got a single point of failure, software architecture. The hard parts really emphasizes how tricky data management can be in a distributed system.
Right, because you don't want one little database issue to take down your entire system.
Exactly. It's like if all the houses in your neighborhood share the same water main and that main breaks, everyone's in trouble.
So how did the CSOP squad solve this? Did they create like separate databases for each microservice?
That's one approach, but it has its own trade-offs too. The
Yeah.
book talks about how they really had to analyze the dependencies between their services. Like,
Yeah.
how often does this service need to talk to that service? What kind of data consistency do we need?
Right, so it's not a one-size-fits-all solution. It's about understanding the needs of your specific system.
Exactly. And that's where those entangled dimensions I mentioned earlier come into play. They can really trip you up if you're not careful.
Entangled dimensions. Okay, you're going to have to refresh my memory on that one.
Right. So remember how we were talking about how changes in one part of the system can have ripple effects elsewhere?
Yeah, the butterfly effect.
Yeah, exactly. Well, entangled dimensions are those areas where different concerns like performance, security, data consistency, they're all kind of matched together.
So it's like trying to untangle a giant knot of Christmas lights. You pull on one string, and it just makes the whole thing tighter.
That's a perfect analogy. And
Yeah.
that's why identifying those entangled dimensions is so important.
Yeah.
Because if you try to make a change without understanding those dependencies, you're just asking for trouble.
Okay, so let's say I've identified these entangled dimensions. What do I do with that information? How can I actually use that to make better decisions about my architecture? Okay, so let's say I've identified these entangled dimensions. What do I do with that information? How can I actually use that to make better decisions about my architecture?
Well, that's where you start asking the really tough questions.
It's like, give me some examples.
Like, okay, we want to make this change to, say, improve performance. But what impact is that going to have on security?
Ooh, yeah, I see what you mean. They're all connected.
Exactly. Or let's say we want to introduce a new feature. Will that make the system harder to maintain in the long run? Will it create new dependencies we haven't even thought about yet?
Right, because it's not just about solving the problem in front of you. It's about anticipating those future headaches.
Precisely. And remember, those fitness functions we were talking about earlier, those could be super helpful here too.
Oh, yeah, the inspectors. They can help us make sure we're not sacrificing like long-term stability for a short-term win.
Totally. You can use those fitness functions to evaluate different solutions, weigh the trade-offs, and make the most informed decision.
So even if I'm not the one writing the code, I can still use these concepts to have a more informed conversation with the developers, with the architects.
Absolutely. And that's so key because software development isn't just about, sitting in a dark room and writing code.
Right. It's a team effort. And understanding these architectural principles, even at a high level, can make you a much more valuable member of that team.
Exactly, because you're bringing a different perspective. You're asking those critical questions that might not have been considered otherwise.
This has been amazing. I feel like I've learned so much about what goes into building really robust, adaptable software.
Me too. It's one of those things that the more you learn, the more you realize you don't know.
Totally. And that's why I love these deep dives because they force us to step outside of our comfort zones and really grapple with these complex ideas.
And, it all comes back to this idea that software architecture is about making conscious choices. It's not about finding the perfect solution because there rarely is one.
Right. It's about understanding the trade-offs, the dependencies, the potential pitfalls, and making the best decision you can with the information you have.
And being willing to adapt and evolve as your understanding grows.
I love that. So to our listeners out there, even if you're not a software architect, remember that these concepts are still relevant to you no matter what your role is in the tech world.
Because understanding how software is built, how those decisions are made, it gives you a huge advantage.
Exactly. And if you really want to go down the rabbit hole, clean architecture has this fascinating concept called Conway's Law, which basically says that the structure of your software will end up mirroring the structure of your organization.
Oh yeah, that's a good one. So if your company is really siloed and doesn't communicate well, chances are your software is going to reflect that.
It makes so much sense. It's like looking at a piece of code and being able to see the fingerprints of the organization that created it.
Exactly. So to our listeners, we'll leave you with this thought. Take a look at the software your company uses every day. What does it tell you about your organization?
Ooh, that's a good one to ponder. And on that note, we're going to wrap up this deep dive into the fascinating world of software architecture.
Thanks for joining us.
It's been an absolute pleasure exploring these ideas with you all. Until next time.